So to lead things off, we have Brad Carlson from the Extension Service. Thank you very much. Brad is the Extension Educator at the U and works in water resource areas with focus on issues related to soils, fertility, water quality, and drainage. Welcome, Brad.
I think this one probably. All right. Well, this presentation is obviously region specific and not the region that we're in. So, as I think a lot of you know me, I work with nitrogen pretty extensively, and so when Fabian was putting this thing together in the fall, kind of before he left, he said, "Well, I want you to talk about that," and I said, "Well." Sure, they want to hear about it in St. Cloud. And he said, oh, I know this is a statewide conference. And besides that, there's a lot of lessons that can be learned in other parts of the state. So I am going to give an overview of what's going on in Southeast Minnesota. This presentation I'm going to give is sort of an aggregation of a lot of stuff. You know, one of the things I've kind of come upon over the years is one of the values that you get from an extension educator is we tend to grab a lot of information from all over the place to tell our story. Our specialists, our researchers, obviously by just the nature of what they do, they're going to come up here, they're going to say, here's my project, here's how we did it, here's the data, and here's what it means. And as an educator, I say, well, here's some data from this study and this study and this study, and here's some basic science, and here's some history, and here's stuff from about 6 or 7 different places that we're going to put all together to tell a single story. So this effort on dealing with Southeast Minnesota was sort of a directive, and I think a lot of you know I work really closely with corn. I think you just heard that. And they asked if I would put together a extension publication that was sort of comprehensive on looking at what's all going on in the Southeast right now. So I've been working on that a while. In fact, we had a mostly complete draft in early December, but the thing is 22 pages long. And it's been suggested that maybe that's a little bit too much. So we're going to be revising that, maybe breaking it into into separate publications dealing with specific topics or specific audiences. But that's something you can look forward to probably this summer. But for the purposes of today, I am going to go through a lot of just a broad overview of that kind of stuff. I also want to put a little plug in for, and I didn't grab one, I was going to carry it up here, but it doesn't really matter. We do have our nitrogen colleges coming up next week. If you're interested in that, it's our advanced nitrogen smart curriculums that we do. We do 5 different curriculums over 2 days. We're going to be next week on Monday and Tuesday in Hutchinson. Warren's holding those up. In Hutchinson at the Extension office, which is on the McLeod County Fairgrounds. And on Wednesday and Thursday, we're going to be in Mankato at something called the Offsite Events. I can't remember the exact name. It's next to Minnesota Soybean, though, and the address is there. So those sessions are at no cost, thanks to the corn growers picking up the expenses on those. If you're interested in 2 full days of nitrogen beyond the full day you spent here today, I encourage you to take those up. And in addition to that, most of those curriculums are also available on our website to view as complete online courses. So what I'm going to do here the rest of my time is go back to the Southeast, and we're going to talk a little bit about the history. We're going to kind of cover what the current situation is. I'm going to say just a little bit about understanding nitrogen. That's some stuff that you've already heard here today. We're going to take that, our understanding of nitrogen, to the Southeast to kind of interpret what probably has led to the issues down there. We're going to take a little tiny look at some of the Southeast research, and then we're going to end just with moving forward on where do we go from here. So where are we talking about? You can see the green there on I was asked to do this for the sake of online. Down in this part of the state where it's green, that's the karst region. Typically speaking, it's less wind-blown soils. They're silty in texture. The bedrock underneath is limestone, and it tends to be fairly shallow. It's not uncommon to see sinkholes down there and streams that just disappear into the ground and then reappear again. And when we move to the west side of that, there is still loess on the surface, but there's older till underneath that. And so there's sort of a transition zone that behaves kind of differently than the rest of the Southeast. And that's probably an important distinction. This is a different, little different view here. I've been working with Joe Brennan from NRCS, our state soil scientist, has helped me with some of the GIS products that are going to be in the new publication. This is depth to bedrock, and so you can see where it's all red there in the southeast. Those are the shallow soils. So primarily what we're talking about here is Goodhue, Wabasha, Olmsted, Winona, Fillmore, and Houston counties. There's portions of Dakota, although a big chunk of Dakota has coarse textured sandy soils, so it's even though it's got some of that geology underneath it, that's a whole separate can of worms there. The very upper northeast corner of Rice County is in that zone, but it's only about a township in area. A little sliver of Dodge on the east side, and then a little sliver of Mower on the east side. But for the most part, when we start aggregating data, we leave those bottom counties out because big chunks of those counties are not in the karst region. I do want to point out, this kind of came from something Jeff told me and to remember about this situation. There are coarse textured soils scattered throughout southeast Minnesota. There's another Joe Brennan illustration here. You can see where the orange colored lines are through there. Primarily, we're dealing with low areas where there's alluvial materials that come from rivers. I am not talking today about managing coarse textured soils. That's something completely aside, but it is worth mentioning that there are coarse textured soils scattered throughout the southeast in locations, and particularly, like I just mentioned, Dakota County's got a lot of that, so you can see that on the top, and that's why we frequently don't lump Dakota in with the rest of southeast Minnesota. So going to some of the history, if I went back to some of the literature, the first documentation of some of this interconnectedness to the surface and the groundwater, the first published study we can find was this dye tracer study in 1941. It had to do with some issues with a creamery in southeast Minnesota that was dumping its waste in a sinkhole, and they were finding water quality problems. I mean, if that wasn't enough to say like, oh yeah, this is causing this problem, they did dump some dye in through that waste stream, and they were able to pick it up the next day. So it showed the first real interconnectedness of that. Kind of aside from all that, so that was in 1941. Methemoglobinemia, the blue baby syndrome, the issue with nitrate toxicity in human infants, was first documented and published in Iowa in 1945. It was documented and published in Minnesota in 1950. And the United States, the precursor to the EPA, EPA did not exist then, established the 10 part per million standard for drinking water in 1963. Kind of while I was gathering data for this or information, I was looking for a foundation of data, and basically what I found out is it doesn't exist. You know, people talk about like, well, you know, they knew that there was high nitrates, and it's all kind of anecdotal because finding anything published showing nitrate test data prior to the 1970s, it literally is not existent. I couldn't find it. I heard it, I saw it referenced to many times, but as far as actual numbers from testing, I couldn't find them. And it makes it sort of difficult when we talk about if we're tracking a trend and what might have caused it, as well as tracking any improvements when we don't have a foundation like that. It's important to remember that Minnesota did not have a well code prior to 1970. So a lot of our wells at that point were uncased and they were shallow. So if you found high nitrates in the well, it did not necessarily mean you had contaminated groundwater. It could have been water washing in from the top and contaminating what was coming back out of the tap. And so prior to there being well standards, that data would be very unreliable anyway. Starting in the 1970s, they did require that when new wells were dug, that water samples were taken and tested for quality. Some of the folks I spoke to, who may even be in this room, suggested that if a number came back high, that it may have just disappeared. So we don't necessarily know even from that standpoint. And of course, that's very random, like where was the well and what was the number? And I mean, it just would be a scattered group of numbers anyway. The very first comprehensive database of water testing in southeast Minnesota started in about 1983 when the southeast Minnesota counties established their own drinking water testing lab, and then they started keeping track of the results. And so that data is actually out there to be seen. And so I went and retrieved the data. It did actually include a couple of the border counties. Dodge was in there and Rice was in there. I could throw those out. I was able to actually exercise those out of the data. And so when you did the math between 1983 and 1990, 14.8% of the water tested through that laboratory in southeast Minnesota tested above the 10 part per million standard. So bring this, up. That started in the 80s. Bring that forward. I think most of you, this has already been referenced. Brandon referenced this. What was the big water quality concern everybody was worried about in the 80s? It was atrazine, right? So we were worried about atrazine. We were worried about allichlor, simazine, some other things. Pesticides were really the big thing. So the Groundwater Protection Act of 1989 that came through the legislature really had a heavy focus on pesticides. Now, it also included nitrates in there. And what's important for our sake is it actually set in motion the development of nitrogen best management practices for Minnesota. So it commissioned the research. The research and the recommendations were to be provided by the University of Minnesota, and then the BMPs are actually owned by the Department of Agriculture. So those got published in 1994. And this is a map that came about more recently from Department of Ag. I think it's really interesting because it shows what they consider to be vulnerable groundwater, and that's what's in red. And the numbers here are the percentage of the cropland that's on top of vulnerable aquifers. And so in southeast Minnesota, 65% of the cropland is sitting on top of what's considered vulnerable water resources, as compared to other parts of the state where it's only 10 and 12%. Of course, the Northeast, we don't have a lot of ag up in that area, so that's not quite as prevalent there. And so coming into the 2010s, there was a lot more money suddenly available from the Clean Water Land of Legacy Amendment. In addition, the GIS capability to actually look at things and track things and really visualize what was going on and finally reached the zenith where it was actually of a lot of use for us as far as tracking this. So this was kind of re-examined, and a initiative went through the Department of Ag to kind of re-examine and comprehensively look at what was all going on. And there was voluntary water testing starting in 2013. The data came back that 13.3% of the samples submitted exceeded 10 part per million. That's actually quite close to the numbers that were obtained in the 80s from that 6-county testing lab, right? And so that came out to be 21 townships that had over 10% of the wells in that township testing above 10 part per million, and another 19 townships that were between 5 and 10%. Furthermore, the Department of Ag established some emphasis on public water drinking supplies, the DWSMAs, drinking water supply management areas. And in the southeast, Altura, Elgin, and Utica were designated as level 2, which meant they were either exceeding 8 parts per million or they had a trend that was going to take them past 10 parts per million within 10 years. And additionally, Chatfield and Plainview were level 1, meaning they were between 5.4 and 8, so kind of on the watch list. I'm not going to go into great detail about that. That's kind of their story to tell. I'm just kind of putting my arms around everything that's going on in the southeast here. But this is something that I find very interesting, and I think you all find it very interesting. If you look at the map of where those townships are that are high, you can see this stripe, this pattern. It's pretty interesting because it's not comprehensive to the whole southeast, is it? It's not on the river, okay? Because those of you that have traveled there know that when you get to the river, it's actually quite rolling and there isn't even a lot of ag land there, right? And it's not farther west really either when the soils start getting a lot deeper. It's primarily where that intersection is where we start seeing the soils really get shallow. We start seeing limestone sticking out of the ground. We see a lot more patchwork of natural areas, and cropland is really where a lot of those problems were kind of identified to be at. And so, conceptually, as far as where we need to look, it's maybe not completely all the way across the southeast Minnesota. It's probably higher emphasis needs to be placed on certain landscapes in the southeast. Okay, What's going on today? There was a petition that was filed with the EPA regarding high nitrates in wells. What was that, 2 years ago now? And it was seeking to do a couple things, one of which was it asked the EPA to take over regulation from the state. That was rejected. However, they did come back and say it was the state's responsibility to supply clean water to folks in that region. And so anybody that's got a high testing water well has some kind of a plan involving reverse osmosis or bottled water or something like that. So that kind of got the ball rolling. More recently, there was a lawsuit regarding the Groundwater Protection Act that I just talked about, that in essence was saying that the rules that were established weren't effective for maintaining water quality for drinking water supplies. Just on September 25th of last year, a judge ruled that the Department of Agriculture had to reopen the groundwater protection rule, which already exists. So we're not talking about writing something new, but open it up for comment. And yeah, but we were talking during lunch, the closing date for that is March 12th. Is that what you said? So the comment period for that is actually open right now. If anybody wanted to submit comments regarding the existing rule. It's not writing a new rule, it's looking at the existing rule and its adequacy. It also was talking about the feedlot rules, but the feedlot laws were already open for being rewritten. So that was sort of a moot point. And again, I'm not going to talk about that. That's a whole talk on its own if you want to talk about the revision of the feedlot rules. Again, I'm just mentioning the fact that that's going on. In addition to that, in the next presentation, you're going to have Matt Drewitz up here, is going to talk about the nutrient reduction strategy, which is calling for a 45% reduction in the amount of nitrogen leaving the state through the Mississippi River, based on a somewhat meager 6% improvement in the last decade. That number is down to about 39%, although that's going to vary from place to place. The main thing I wanted to show you was the map again, and look at southeast Minnesota, where the need is highest, which is the Root and the Zumbro River watersheds down there, where we're calling for the greatest levels of nitrate reduction in surface waters. Now, in addition to that all, something that you may not be familiar with is the fact that the Pollution Control Agency also established what was being referred to as an interim standard for nitrate concentration in streams. Initially, it was only looking at cold water streams, of which is in southeast Minnesota, the trout streams in southeast Minnesota. And the interim standard that was established was 10 parts per million, kind of the drinking water standard. You can see where the red spots are there in the southeast. Those are where the streams that had been deemed to be out of compliance with nitrate concentration standards. Now, who read the 310-page nutrient reduction strategy that became final on January 29th? Come on, I'm not getting a lot of hands out there. If you read it, you saw in there that it alluded to the fact that once the nutrient reduction strategy was final, the Pollution Control Agency was going to come through and enact some final standards for nitrate concentration in surface waters. Those are likely to be 8 part per million statewide, but reduced from 10 to 5 in the southeast in cold water streams. This is a map that comes out of the nutrient reduction strategy. I talked to Matt a little bit about this. I think the initial labeling on the draft was a little bit incorrect because it said these were the streams that probably are out of compliance, but in reality, these are the streams that are probably above 8 parts per million. And so the point being, if the standard in southeast Minnesota is 5, not 8, it's probably going to be even more than that. And so you can kind of look at, you can look at, you're all probably looking at the whole state here and seeing what that means. But for the southeast, there's, a great increase compared to that old one that only had these few spots versus what you've got going on there now. So that is going to continue to be a developing issue too over the next few years. All right, I'm going to change gears because now we've talked about what's going on down there. I'm going to mention, we're going to go a little bit into interpreting kind of what's caused this. So a lot of this is, you guys understand the nitrogen cycle, and we've had a lot of talks about this already. But for the sake of trying to bring everybody up to the same platform here, we'll just go over this, that the nitrogen budget is, for any crop, is a component of the mineralized nitrogen that comes out of the soil organic matter. Legumes are fixing it. Your corn crops, your small grains aren't doing that. And then the fertilizer inputs. If you measure the amount of grain that you achieve at zero added nitrogen, that's a pretty good indicator of how much is being supplied by the soil. As a rule of thumb, we kind of figure there's 1,000 pounds of nitrogen in the soil for every 1% organic matter, okay? So there's several thousands of pounds of nitrogen per acre out there, but it doesn't all release at once. How much releases has a lot to do with environmental conditions, soil health conditions, and so forth. But if you do a nitrogen rate trial, you can look at what you get for a yield at zero and get a fairly good idea of what's being supplied by the soils on site. In Minnesota, if you look at the whole database that Dan talked about first thing this morning, if you look at the whole database of nitrogen rate studies and you average them together, on average at zero nitrogen, we're getting 60% of our yield at zero on corn and 76% for corn following soybeans. So basically speaking, if you got corn and bean rotation, you're chasing the last 24% with your fertilizer. The rest of it's being supplied by the soils. The point of that is to indicate the incredible potential that the soils have to mineralize and supply nitrogen. This is a data set that we've used a lot. Again, this has kind of been covered a little bit today, but this is a little different way of looking at it. This was some of Giles and Jeff's stuff. And the thing I always point out here, this is from the drainage studies, and the really valuable part of the drainage studies is we can just simply collect the water and measure what's in it, okay? We don't have to suck it out. We don't have to go to any extraordinary measures. You can just hold a beaker at the end of it. Now we use a automatic sampling device, collect the water and see what's in there. You can measure it. And so these are 4-year totals. So in the soybean year where we applied no nitrogen, of course, to the soybeans, and then in the zero nitrogen rate for the corn, you can see that we're still averaging about 10 pounds per acre loss through those plots, right? So if you look at the numbers for where a best management practice or recommended rate was applied and do the math, that's only about 15. Now those numbers are going to vary all over the place. It's not important to say these are the numbers, for every field. The concept though that I want to get across is that in this particular case, only about 1/3 of what was coming out of that tile line was attributable to the fertilizer we were applying. We were still losing about 2/3 in this particular instance, even without fertilizer applied. So if the state is if we are looking at as an industry, a reduction in the amount of nitrogen of 45%, what is this telling us? Completely eliminating commercial fertilizer wouldn't even get to that number in this circumstance, right? So it's going to take some other stuff. Why is that happening? Well, okay, we know that. It's because we continue to mineralize nitrogen as long as the soil is warm and moist. So this is a microbial process, and as most of you know, we don't recommend applying nitrogen in the fall until the soil temperature goes below 50 degrees. That's because the soil will act like your refrigerator at home. You don't want to store leftovers in a refrigerator that's above 50 degrees. In fact, you'd prefer it to be a lot colder than that. It'd go bad if it was warmer than that. That's why we don't want nitrogen in the soil until the soil temperature goes below 50 degrees. That's because that's the point at which we start to significantly slow that microbial action, right? If you look at the averages, that date, and using Waseca's data, and it doesn't matter that Waseca is not in the southeast, it's still the same latitude, roughly speaking. And besides that, it's going to be different every year anyway. So if you look at Waseca, you can see that the average date that we're at 50 degrees soil temperature runs from April 1st to October 18th. And if you look at the frost-free date, when this starts really at a very slow level and starts ramping up, the average first frost-free date at Waseca is March 17th, St. Patrick's Day, and it freezes on average on December 7th, okay? So that's the window. Now, compare that to the crops that we grow. We typically reach physiological maturity for most of our corn, roughly speaking, around Labor Day, right? I mean, at that point, there's not a lot of nitrogen being taken up anymore. So from September 1st until October 18th, we still have ideal conditions to mineralize nitrogen in that field, and there's nothing growing out there, okay? That's a big chunk of what we're losing from that tile line. Okay, it's an artifact of our cropping system, and it doesn't really have to do with how we're managing nitrogen fertilizer inputs. And how do we know that? Well, here's another data set, another one that I've used extensively. This was one Giles did years ago at Lamberton, where they had alfalfa and native grasses, and you can see that the nitrogen loss there was almost nothing. Okay, so as long as there was a living plant there from the time the ground thawed out to the time it froze, we see that that number can go down to practically zero, right? Now, some people want to blame, well, you know, then we got to start growing perennials. The point I like to make to everybody is go to the grocery store, fill your cart up, and then tell me how much in that cart was a perennial. Maybe some apples and some oranges, okay? And maybe you bought some almonds, but almost everything you bought in that grocery store was an annual plant, okay? Or it was meat from a creature that ate an annual plant other than beef, which of course is a, they're able to, a ruminant is able to eat forages. So southeast Minnesota, which has a rolling topography, has typically favored the dairy industry, which of course has longer crop rotations and alfalfa in it. And traditionally, there was a lot of pasture land in the southeast. Here's the money shot right here, okay? Here's the acreage in those 6 counties and looking at the crops. I pulled this number out of the Census Agriculture data. Now, some people might say, well, see there, that's corn's fault. It's not really corn's fault. The fault is, look at the alfalfa number, or hay number, which is the gold bar, and look at it plummet. Look at the pasture number, which is hard to pick out, the blue bar there. It plummets to almost nothing, okay? And it's really is the loss of perennial crops in the southeast that's probably more to attribute to this than almost anything. If you look at the black bar, and I realize it's hard to pick out the black from the blue bar on there, that's the number of dairy cows in southeast Minnesota. And while the dynamics of the dairy industry have changed a lot, the number of cows in the region actually hasn't changed all that much. Okay, their distribution is different, right? And we can kind of assume, I suppose, a modern dairy cow is eating more than a cow did in the 1950s, but the consumption of forage is about the same, but the nature of the industry is different, as is our precipitation pattern. You know, the joke we used to say as an extension agent is in Minnesota, it takes 3 dry days to put up hay, and we average rain every 2.2, okay? And that's fairly accurate. And so really, from a risk management standpoint, an awful lot of the dairies have simply decided that they're going to purchase hay inputs and not take a gamble on whether they're going to be able to put up a hay crop this year. And that's really kind of what's happened, okay? So the loss of that perennial cover has really been a major factor. All right, let's shift a little bit into the research on the stuff that developed our best management practices. I'll point out here, this is some of Giles' stuff from the late 80s and early 90s. The one thing I want to look at here was when we were looking at fall application. Here's the nitrate concentration here at 150 pounds applied nitrogen, and then here's the spring one. So, you know, we're dealing with a roughly 30–40% increase when there was a fall application, and the data was pretty clear, and it didn't matter whether N-Serve was used or not, that fall applications in the southeast just didn't look good. And so here's some recent data Jeff supplied to me. We actually were using a data chunk from the Waller farm in Rochester for many years, and when we were doing this publication, he said, let's get a new graph. And this one I want to point out from this particular site here in Harmony. You can see this nice response curve for nitrogen there in the gold box where the MRTN is. But look at the residual soil nitrate there. It's pretty much linear. It's not zero. Remember what we said? It's going to continue to mineralize nitrogen. But the crop does a pretty good job of scouring that nitrogen until we get to the MRTN rate. And then it's a linear increase. And basically speaking, if we apply nitrogen above the MRTN, we're pretty much pound for pound leaving it behind in the field. And so really the crux of nitrogen management is try and figure out exactly what that crop needs and not be applying more. Dan already talked about this, that we're probably going to be changing the nitrogen rate recommendations for southeast Minnesota. So I'll kind of blow by that. But this is another interesting piece of some of Jeff's data that he presented. I think he might have presented it last year at the nitrogen conference. This is a accumulation of a lot of nitrogen rate trials. So for the sake of the folks who say, yeah, but I need more, okay? So the one thing that we like to point out, Jeff's got this shaded in here where the MRTN window is, but I want you to take a look at these boxes right here, or these plots right here where these particular sites required higher nitrogen, and take a look at what happens right here. They all came down here. Basically speaking, you were able to predict whether you needed excessively more than MRTN based on how much yield you got at zero nitrogen rate, okay? So that really is kind of a site indicator. Now, Jeff says that those sites tended to be toward that western side where we had that lust cap and that heavier old till soil below it, okay? So that's another justification for why we're probably going to end up separating those, that region out of the karst area in the nitrogen rate calculator. A complicating factor, if you watched last year, Kevin Keener from Department of Ag gave a presentation where they did this novel study looking at the age of groundwater in southeast Minnesota based on analysis of the degradation of allichlor. And they discovered that most of the water in the southeast was 15 to 30 years old when they were pulling the samples out, okay? What was interesting about that, though, while it's difficult to interpret the exact trends, the older water, the 30-year-old stuff, showed the trend that it was still getting worse, but the 15-year-old stuff had stabilized and somewhat started to get better. So it makes it difficult to say, you know, one, you make a lot of changes in how we're managing, okay, you're not going to see the results right away. It might be 15 years before you actually see those, okay? Number two, if we've seen those numbers stabilize and maybe even start to improve, we may have actually turned the corner. So it's very hard to know exactly what the situation is, but it's a complicating factor in all this. So how are we going to address this? Well, I think most of you know that the Department of Ag has enacted a fall nitrogen ban. Nobody really got too uptight about this because you know, we've been saying for 30 years don't apply in the fall anyway. So that's the southeast there, and the purple areas are where you're no longer allowed to apply. We are advocating a switch from MAP and DAP sources of phosphorus to triple superphosphate for fall application because there's no nitrogen in that fertilizer. That had been available, at least by one of the major co-ops in the southeast until this year. There was shipping issues relative to some of the trade stuff and they couldn't get it this year. But in the long run, you know, what we've kind of found is TSP, which actually was a dominant phosphorus fertilizer source in this state through the 1970s. And so it's not unheard of. It just simply fell out of favor. That could be a part of the solution to reduce the loss of the nitrogen from those fertilizers when they're applied in the fall. The decrease of the nitrogen rate recommendations, that will come with the splitting of the rate calculator. Emphasis on split application. Well, good. The emphasis on split application. When I talked to Jeff about some of the rate trials he's been doing, he says, we don't necessarily see a yield increase with split application, but we see a decrease in the MRTN. You can actually get the same yield with less applied nitrogen. And what that really amounts to, from my perspective, is it's more consistency and it's eliminating some of the factors that are limiting your yield, okay? So, you know, one of the pieces of data we show often when we teach Nitrogen Smart, and some of you have seen that shotgun blast pattern that looks at the yield at MRTN, and it says why nitrogen rate doesn't follow 1.2 times bushels, because if it did, it would be on a straight line. Instead, it's this big blast. Why is that? It's because something other than nitrogen is controlling the limiting yield factor there, okay? Okay, that's what's going on. And so by split applying, we can probably eliminate some of those other factors and get more close into exactly what it is, you know, what the exact nitrogen needs are for the crop. What about manure? One of the things that I discovered through this is we actually in Minnesota, we have not had any fall application timing studies with manure in southeast Minnesota. Right? It's a big gap in our information. So, what we can say is follow the BMPs, consider additional measures, use the PPNT to determine kind of what your residual is. Split applying might be an option, and nitrification inhibitors, use of cover crops, and so forth are going to be part of this. So, in the bigger picture, in the long term, I think continuous living cover, using cover crops and perennials are probably going to be part of this. I think technology is going to continue to advance. So where we may be discovering that there's actually places on the landscape that are more sensitive than others. And so that we may be able to do targeted set aside, maybe not widespread, just we have to abandon farming, but there may be actually areas where we get better bang for our buck from just simply stopping farming some of those spots. I think that there's a great opportunity right now to expand the beef industry in southeast Minnesota. It's not very likely that we're going to see a lot of dairy herds go back to the old way. But I think most of you are familiar with what's currently going on in agriculture, realize that, there's kind of a shortage of beef cows in this country. And I think that would give us the opportunity, for putting some more perennials out there in pasture and so forth. And so I think that's something that I think is at least worth looking at. So just about wrapped up here. We're going to have 2 meetings coming up in addition to those nitrogen colleges that I plugged that are next week. We are going to have a day-long session in the Southeast on March 2nd in Fountain at the Community Center, on March 3rd in the VFW from 9 to 3. We are providing a lunch, and therefore we do ask that you pre-register for that. It is on our webpage, z.umn.edu, Nitrogen Smart. If you hit that QR code, you'll get to that webpage. That's, again, courtesy of Minnesota Corn. And that is what I have. I thank you. And as I've said before, the Minnesota Corn has supported an awful lot of the stuff that I do. So I need to thank them for that. And I wouldn't be doing this specific thing if it wasn't for the fact that they were asking for it. So that's kind of where we're at. So with that, what is that based on? That is not a me question. That is an MPCA question. That is contained in the nutrient reduction strategy. And I'm not even sure, Matt, you are talking later, but I don't know that you're an expert on that either. But my understanding has been it is based on invertebrates in those streams, which are feed for the trout, not the trout themselves. And that's all the more I know. I've actually asked what invertebrates, and I've gotten kind of a, so that's what I can tell you. So I'm sorry, but I can't answer that question, and I'm not the one setting that standard. So thoughts on split applications versus urea blends with products like ESN Super U. Okay, so that's the other thing about this is in addition to split applying, potentially allowing us to dial back nitrogen rates and get the same yield, I think it's possible. We need to start looking at, can we use ESN as part of that? Maybe potentially a nitrification inhibitor like Instinct with urea. Now, I don't really like the performance of that broadcast, but banded that might offer some protection that might do some of this also. I think there's a few things that can be examined that we haven't looked at very closely. Historically speaking, we have judged whether something works or not based on whether it provides a yield increase. We need to get away from that. Okay, if it provides a ability to reduce the amount of time you put into management, if it's a reduction in loss to the environment, those are also things that work, in my opinion. It doesn't necessarily always have to increase the yield if it produces some kind of a positive result in some other way. And so I think we do need to expand our definition of that. So anything else? Yes.
Yeah, you showed a slide for the fall. You lost or a lot of nitrogen went into the waterway. Was that urea or anhydrous? Or what
that would have been anhydrous in that study. That was, those, I was, to age myself, I think actually this was after you, Jeff. But I was an intern at the SROC when those studies were going on. I actually had to take 3-foot soil samples, and and so forth. So pulling out water suction lysimeters and so forth. But yeah, that was when I was there well, I guess I started there in 90, and I think were you there at 89 still? No, so you didn't do that, but I did. So yeah.
All right, let's
Okay.
wrap it up.
All right.
Thank you very much, Brad.